All right, remember my last video when I said, oh look, we have the equation of a tangent line, and I'm like, oh wait, no, not the equation of a tangent line, we have the equation of the slope of a tangent line. It's because there's a kind of big difference. When we're finding the derivative, we find a function that gives us the equation for the slope of a tangent line, okay? So when we put in an x value, we get out a slope, we get out a number, all right? But when we want to find the equation of a line, we use that slope along with a point to write the actual equation of that tangent line. So once we found the slope of the line, we still want to then have the equation of that line. Okay, so let's look at what that looks like. So first we're just going to talk about writing the equation of a tangent line. Basically, use the derivative, find a slope, and write the equation for the line. So find the equation of the line tangent to this function, which is probably right in the glare, sorry, at 0.16. So first we're going to find the derivative, because that's going to help us get the slope. So we bring our 5 down, we get 20x to the 4th. We bring our 2 down and we get 6x to the 1st, because 2 minus 1 is 1, and then plus 5, well, the derivative of a constant is 0. So I have this function, f prime of x equals that. Now I need to find the slope of this line at a point. Well, when I'm writing the equation of a line, the slope needs to be a number, right? I can't just then like plug this in, right? Because this is a curve. So the slope of the tangent line is constantly changing. So we're looking for instantaneous rate of change. We're looking at that exact point, x equals 1. What is the slope of my line? Okay, so we're going to f prime of 1 equals 20 times 1 to the 4th minus 6 times 1, which gives us 14. So the slope of the line at this point at 1 is 14. So now all we have to do is write the equation. Well, we have the slope, we have a point, so there you go, you're done. That's the equation of the tangent line to this curve at that point. So there's this other line that we're going to talk about, though, called the normal line. So sometimes we want to find the line perpendicular to the tangent line at a certain point, and that's what we call the normal line. So we know how to find a perpendicular line, right? It's the slopes are just opposite reciprocals. So we change the sign and flip it. The sign in sign language, the sign for reciprocal is this. So it's really easy to think about like opposite reciprocals. Okay, so the equation of the normal line would be through the same point, it would just have an opposite reciprocal slope. So m of the tangent line, right, the slope of the tangent line is 14. So the slope of the normal line is negative 1/14. And then we have y minus 6 equals negative 1/14 x minus 1. And that's it. That's how you find the equation of a line tangent to a curve.